So a polygon is a shape formed by 3 or more intersecting line segments, such that at most 2 line segments intersect at one point, and each segment meets exactly 2 other segments. So from this definition, they are telling us that polygon must be formed with line segments. So it must be formed by lines, not curve. And it must be line segment, meaning a segment, from the definition, a segment is just a line that has endpoints. So like this line here, this is a line segment. So it has the endpoint. So we are going to form a polygon using line segments. That's the first key point. Secondly, it must be 3 or more. So we can't form a polygon with only 1 or 2 line segments. It must be 3 or more line segments. And also, at most, 2 line segments meet at a point. So at every point, only 2 line segments will meet there. And each of the line segments will meet exactly 2 other line segments. So let's form a polygon. So like this one line is not a polygon because we have only 1 segment. So let me duplicate it. I have 2. So this is not a line segment. This is not a polygon. Though from the definition, 2 meet at a point. So they met at this point, but yet it's not a polygon because you have only 2 segments. So finally, let me add. We have 3 line segments, but you can't call this a polygon because they say that each line segment must intersect other 2 line segments. So you see that line segment 1 intersected 2, but the other 2, this and this, intersected only 1. So it's not yet a polygon. Okay, finally. Okay. Exactly, this is now a polygon because we have 3 line segments and each of them intersects 2 other line segments. So this is a polygon. Okay, look at this. This is not a polygon because this is not a polygon because at this point 3 line segments meet at a point, but from the definition they told us it must be only 2 at every intersection. So but we have 3. So this is not a polygon. So that's it. So this is not a polygon. And maybe let me form another polygon. This is a polygon. This is a polygon, yes, because at every intersection we have only 2 line segments. Okay, from the definition, since they told us that it must be 3 or more line segments, so the smallest sided polygon is a triangle because we have 3 sides. So the 3-sided polygon is called a triangle. 4-sided is called a quadrilateral. 5-sided is called a pentagon. 6-sided polygon is called a hexagon. 7, heptagon. 8, octagon. 9, nonagon. 10, decagon. We still have others, but for this lesson, we are going to learn only 10. But most questions will revolve under this 10. So we are done with that. So the next specific objective is to find number of diagonals. So as you can see, they said every vertex of a polygon has 2 adjacent vertices and n-3 non-adjacent vertices. And we'll form a diagonal by joining 2 non-adjacent vertices. So let me now tell you what a non-adjacent vertex is and also what an adjacent vertex is. Okay, let me just get this line segment. Let me copy it. change the color so that we can see. Okay. So a non-adjacent vertex is the okay. Let me use vertex B. So see the vertices in this. This is a four-sided polygon. This is a quadrilateral. 1, 2, 3, 4. So let's look at vertex B. A and C are the adjacent vertices of B. Do you get? So the one that forms a side of that polygon. So for vertex B, A and C are the adjacent vertices. So the vertex that forms a side is the adjacent, while the non-adjacent is the one that forms the diagonal. So for B, the adjacent vertices are A and C, while D is the non-adjacent vertex. So that's it. So that's what we are trying to, that's what we are saying. So from here, you notice that they said every vertex must have n minus 3. And of course, in any polygon, n is the side. So if n is the side, for us to get non-adjacent vertices, we will subtract 3. Because we have 2 adjacent. And if you now do n is 4 in this case, so 4 minus 3 is 1. Have you seen why we have only one D as the non-adjacent vertices? For 5-sided, each of them will now have 2. Because the sides, we have 5 sides, so 5 minus 3. So each of them will have 2 non-adjacent vertices. So coming to the major thing, because we are trying to form a diagonal. So a diagonal is formed if you join 2 non-adjacent. So for this, for the first one, which is a quadrilateral, the diagonal, we have this is the diagonal, and also this is the diagonal when we join 2 non-adjacent vertices. So we have 2 diagonals, as you can see. So for this, for the second polygon, which is a pentagon, we have this, we have this. So we are done with vertex F. So for each one, you join the non-adjacent vertices. So let's move to vertex E. So vertex F, we have 2. And vertex E, we still have yes. And finally, we have for this so I think we are done. No more diagonal. So let's look. For I have this. For H, I have that. I have. So that's it. We are done with this. Y for 6 sides. Let's start with vertex N. So that's 1. That's 2. And that's 3. So we are done with vertex N. So let's check for M. One, And finally, three. From what we said, n minus 3 non-adjacent. So in this case, we have 6 sides. So each of them will have 3 non-adjacent vertices. Why? That's one. This is the second one. And finally, that's the third one. So for K, we have 1, 2, so we have only one left. So that's it. We have any other J, we have 1, 2, 3. 1, 2, 3. So let's now count. You notice we have something that we'll get a formula from this. So for the first, let me use for this quadrilateral, what do you notice? We have 2 diagonals, so we have 4 sides. 4 sides. We have 2 diagonals. Why for this? We have 5 sides. And how many diagonals? We have 1, 2, 3, 4, 5. Yes. So we have 5 diagonals. So for the 6-sided polygon, let's count. 1, 2, 3. Okay, let me be count so that we won't repeat. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. No repetition. 9. Okay, we have 9. So we have 6 sides and we have 9 diagonals. So we can't just continue counting like this. We want to get a formula for that. So what do you notice? Since we can use our common sense here, since each vertex, since we are forming a diagonal with non-adjacent vertices, and each of the vertices will have n minus 3 vertices, non-adjacent vertices. So the total diagonal, that's the total, since one has n minus 3 non-adjacent vertices, if we now have n vertices, so the total will be n times n minus 3. Do you get the logic? 1 will have n minus 3. So 2 will still have its own n minus 3. So for n vertices, it will have n minus, total of n times n minus 3 non-adjacents, forming the diagonal. But there is a problem here. Some of the vertices are repeated. Some of the diagonals are repeated. So to avoid repetition, we now divide by 2. So I'm now saying generally, the number of diagonals of any polygon is always equal to n times n minus 3 over 2. Yes. Over 2 to avoid repetition. So let's test whether we are correct. For 4 sides, we have 4. 4 minus 3 is 1. So 4 times 1, 4 over 2. So we have 2 diagonals. So for this, I have 5 times 5 minus 3, which is 2 over 2. So we have 5 diagonals. And finally for this, we have n is 6. So 6 times 6 minus 3 over 2. 6 minus 3 is 3. 6 over 2 is 3. So 3 times 3 is 9. They said, find the number of diagonals of the following polygon. So for the first one, so for an octagon is an 8-sided polygon. So n is 8. Therefore, the number of diagonals is now 8 minus 3 over 2. So I have 8 over 2 is 4. 4 times over 2, which is 9 times 9 minus 3 is 6 over 2, which is 9 times 6 over 2 is 3. So we have 27 diagonals. And finally, decagon. A decagon is a 10-sided polygon. So we have 10 times 10 minus 3 over 2. So we have 5 times 7. So we have that 5 diagonals. So we've learned how to solve to get the number of diagonals given the polygon. So we are done with that. Subtopic is relationship between an interior angle and its corresponding exterior angle. So let me use the example. I have a 3-sided polygon, which is a triangle. So we have, in any polygon, the number of vertices equals number of interior angles. So I'm saying that number of vertices equals number of interior angles also equals number of exterior angles also equals number of sides. So whenever you're given that's the total number of vertices, we still have the total number of sides. Like this, we have 3 vertices, 1, 2, 3, and we have 3 sides, and we still have interior angle. See, look at the interior angle, maybe A, B, and C. We still have an exterior angle is formed if you extend one of the sides. So this is the exterior. This is the exterior to C. YE is the exterior to A. Y this is the exterior to B. So we have 3 exterior, 3 interior, 3 vertices, 3 sides. So there is a relationship connected. As you can see, this is a straight line. What do you notice? We form a linear pair, that's angle on a straight line. So what do you have to say here? We'll notice that if you sum the sum of the interior, that's any interior angle, plus the corresponding exterior angle must be equal to 180 degrees. Yes, based on angle on a straight line. So that's the relationship connecting interior and its corresponding exterior angle. We still solve questions on this. Let's know the foundation before we move to questions, real technical questions. So we're on number of non-intersecting triangles. Non-intersecting triangles. So let me just, okay. Non-intersecting triangle. So in any polygon we can form triangle inside. Yes. And how do you do it? If we join vertices, that's non-adjacent vertex, like forming a diagonal. Once a diagonal is formed, triangle will be formed. So that's what we are going to do. We want to get a formula from the number of non-intersecting triangles in a polygon. So as you can see, we have 3-sided polygon. This is 3 sides. We have only one triangle, as you can see. We have one triangle, because we have 3 sides. But looking at this, let's join vertex B and D. We now form 2 triangles. Yes, we have 2 triangles. So we have 4 sides. How many triangles? two non-intersecting triangles. So looking at this one, the last one, before we get a general formula for that, we have this. Remember, non-intersecting. So they will not intersect, because we can still join H to K, but it will intersect. This is okay. So that's it. We have how many triangles? 3. 1, 2, and 3. So, since we have 5 sides, we have 5 sides. 5 sides. How many triangles? 3 triangles. So what do you notice here? You notice the difference. What's 3 minus 1? 2, right? 4 minus 2, 2. 5 minus 3, 2. So it's always constant. So how do you get number of intersecting? So generally, for n-sided polygon, we have n minus 2 non-intersecting triangles inside the polygon. So this is a very important formula. It will help us to get the sum of the interior angles of a polygon. So let's move to, okay, let's just solve the equation. First one, we ask find the number of non-intersecting triangles of the following polygon. So the first one, so octagon is that's the number of sides is 8, which implies it will have 8 minus 2 non-intersecting triangles. So we have 6 non-intersecting triangles. While the second one, nonagon, is 9 sides. So it will have 9 minus 2, which is 7 non-intersecting triangles. And finally, decagon is 10 sides. So we have 10 minus 2, which is 8 non-intersecting triangles. So with that, let's look at some of the interior angles of a polygon. This will help us, the number of non-intersecting triangles. So what I will do, let me just, okay. Let me copy this and paste once. So we are going to get a formula. So since we've gotten number of non-intersecting triangles, we can get the sum of the interior angles of these polygons. Yes, we're going to get a formula. So what do you notice? Here we have 3 sides. We have 1 non-intersecting triangle. Yes. But for here, we have 4 sides. And we have how many non-intersecting? 2 triangles. We have 5 sides. We have 3 triangles. So if I want to get the sum of the interior angles, it's simple. So what do you know? What can you deduce from this? We can get the sum. This is 1 triangle. So the sum of the angles will now be number of non-intersecting triangles. That's 1 times 1, 8. Yes. Where 1 is the number of non-intersecting triangles in it. So what of this? We have 2. So 2, 1, this is 180, this is the second 180. So the sum of the interior angles will now be 2 times 180 degrees. Coming here, the sum of the interior angles is now 3 times 180 because we have 3 of them. 1, 2, 1, this is 1, this is 2, and this is 3. So from here we can now deduce another formula. We now get a general formula. So generally, the sum of the interior angles of a polygon is equal to n minus 2. That is the number of non-intersecting triangle times 180. So this is a formula. This is a special formula for the sum of the interior angles of a polygon. So let's use it and solve. Maybe let's solve the question. So they said find the sum of the interior angle of a nonagon. So that's the first question. So I can partition this. Let me partition it into 3 so that we solve fast. So the first one, number 1, a nonagon is a 9-sided polygon. So the sum of the interior angles is now equal to 9 minus 2 times 180, which is 7 times 180. So our answer is 0. That's 0. This is 6. Carry 5 plus 5. That's 1,260 degrees. So this is the sum of all the interior angles of this polygon. While the second one, they say the interior angle of a polygon are 1, 2, 3, 4, 5, 6. Find the value of x. So this is a technical question. So let me move this so that we'll have more space. So for the second one, as you can see, remember how many interior angles are here? 1, 2, 3, 4, 5, 6. Meaning that the number of sides is 6. I've told you earlier that the number of vertices is always equal to the number of interior angles, number of exterior angles, number of the vertices. So we are given 6 interior angles, we have 6-sided polygon. And they said we should find the value of x. So we now use a logic. Since we've known all the angles, we know that if you sum it, it must give us n minus 2 times 180, where n is 6. So I'm saying that if you add x plus 10 degrees plus x minus 20 degrees, we'll have plus 2x minus 10 plus x plus 40 plus 3x minus 10 plus 2x plus 30 must be equal to the sum, which is n. Our n is 6 minus 2 times 180. So sum this is equal to 10x. Summing the ones with x, 1, 2, 4, 5, 8, 10. So let's add the other. 10 minus 20 is minus 10. Minus 10 minus 10 is minus 20. Minus 20 plus 40 is plus 20. Plus 20 minus 10 is 10. And 10 plus 30 is 40. So that's it. Equal to 4 times 180 degrees. Because 6 minus 2 is that. So as you can see, 4 times 180 is 720. Right? Yes, 720. So this is 10x plus 4. Remember the degrees they are gone. So what you have to say, 720 minus 40. So I have 10x equal to 720 minus that is 6. That should be 680. And finally, x is 680 divided by 10, which is 68. As I did 680 over 10, which is 68. So the x value is 68. So it's a technical question. So finally, the last one, they said the sum of the interior angles of a pentagon is 6x plus 6y. We are asked to find y in terms of x. Whenever you're asked to find y, something in terms of something, they're telling us to make y to stand alone. That move it to the other side of the equation. Let it stand alone. You now move others to the other side. Depending if you want it to be in left hand side, you keep it there, while you move others to the right hand side. Or if you want it to be in the right hand side, you move others. That's the meaning. So we make it the subject of formula. That's the second way of saying writing something in terms of the other thing, is to make it the subject of formula. Just keep it in one side of the equation. So that's it. They told us this is a pentagon, and they gave us the sum. A pentagon, the sum is 5 minus 2 times 180. And also they gave us the sum as 6x plus 6y. Do you get the logic? They gave us the sum. We know the sum as n minus 2 times 180. But they still gave us the sum as 6x plus. So we equate it, forming an equation. So I have 5 minus 2 is 3. So I have 3 times 180 equals, in mathematics, to make our solution easier, I have 6x and I have 6y. We can bring out 6 and we'll have x plus 1. That's factorization. Factorization, just bring out a common term, maybe the HCF. Bring out what is common in both. You now write there. That's the meaning. That's what I did here. So that we can leave our answer to the simplest form possible. So let's create another slide so that we'll continue. The last, okay, we're left with 3 times 180. I normally use asterisk to differentiate it from x. 6 bracket x plus 1. So what do you notice? I can move my 6 to this side to be here. That's to dividing both sides by 6. So we're still on the right track. The next one, we can divide. 3 in 6 is 2. 2 in 180 is 90. But they told us to make y to stand alone. So y standing alone, y stands alone, yx moves. So we have 90 minus x. So that's it. That's our answer. We've made y the subject of formula, or we've written it in terms of x. Slide. We have sum of the exterior angles. We've gotten the formula for the interior and the sum of the interior angles. We want to get the formula for the sum of the exterior angle, and the polygon I'm going to use here is a triangle, the smallest sided polygon. So let's now denote. If I call this A, call this B, call this C, call this D, call this E, and call this F. So what do you notice? We have that each of them form a linear pair. So we have A plus D is 180. Yes, angle on a straight. That's from our basic geometry. If you sum the angle on a straight line, it gives us 180. So the same way, B plus E is also 180. Yes, still based on the same argument. And this is C plus F is still 180. Yes, the same. So we have 3 equations. If we sum the three equations, let's sum equation 1 and 2. 1, 2, and 3. So I'm summing now. A plus B, A plus D, plus B plus E, plus C plus F. I've summed this, and this, like summing at the left hand side, which is the same as summing these three, 180, 180, 180, which means 3 times 180. You get, we have 180 3 times, so to make it easier, we have 3 times 180. And again, what are the interior angles here? A, B, and C. So you know, addition is commutative. If I add 2 plus 3, I can still write it as 3 plus 2. So I will rearrange this. Instead of writing A plus D plus B plus E, I will write, let me sum A plus B plus C as 1 and sum the exterior angles, which are D plus E plus F. So we are still correct. We are still on the right track. And from this, A plus B plus C is a triangle. That is, the sum is 180. So I have 180 degrees. Plus D plus E plus F is the sum. We are looking for sum of the exterior angles, which is now equal to 3 times 180. Yes. Basically, D plus E plus F are the exterior angle. We are looking for the sum. So we're getting a formula. Therefore, what do you have to say? You see that sum of the exterior angles of a polygon. From this means 3 times 180 minus 180. Yes. So we'll move this 180 to the left, to the right hand side to be negative. And 3 times 180 is 540. And what is 540 minus 180? We have 360. So this answer is always true for all polygon. It's a constant. So whenever you sum the exterior angles, you always get 360 degrees. So this is the formula for the sum of the exterior angle of a polygon, no matter the side. I just use 3 sides so that it will be easy for us to derive. So we've gotten the formula. So let's answer these questions first. Look at this. You see, we are given the exterior angles and we're asked to find the value of x. Without wasting time, how many sides we have? We'll sum 1, 2, 3. So let's sum. We've gotten that the sum of the exterior angles of a polygon is 360. And what are the sides? We have 3x plus x plus x plus 5x plus 2x must give us 360 degrees. So 3x plus x is 4x, 5x, 10x, 12x is equal to 360. So what do you have to say? 360 divided by 12. We have 30. So x is 30 degrees. So it's a fast one. So once you know the formula for the sum of the exterior angle, we'll solve these questions fast. So the second one, they said the only polygon that the sum of the interior angle is equal to the sum of the exterior angle is dash. This is also a fast one. You can solve it using this is a word problem. They said the only polygon that the sum of the interior angles equals sum of the exterior angles. So we'll form an equation. So once we know n, we now know the name. You know, from the name, once you know the sides, we can name it. Because that is what we are asked to solve, the name. So let the polygon, let n be the number of sides. So let n equal to the number of sides of the polygon. Therefore, from here, the sum of the interior angle of any polygon is n minus 2 times 180. And it must be equal to the exterior, which is 360. That's it. We solve for n. Once we know the n, once we know the value of n, we've known the name of the polygon. So from here, we divide by 180. So this is n minus 2. And what is 360 divided by 180? We'll have 2. Therefore, n minus 2 is 2, implies that n is 2 plus 2, which is 4. So we have four-sided polygon, and our answer, the only polygon, is quadrilateral. So the polygon must be a quadrilateral. So that's it. Okay, look at this technical question. We ask, in a polygon, two of the exterior angles are 30 and 60, and the remaining angles are each equal to 27. Find the sum of the, find the sum of the interior angles. Okay, this is a technical one, but we can still solve it. Remember, number of sides equals number of exterior angles. So since we are given 2, we know that we're already given 2 sides. So we need to get the remaining sides. So let the remaining angle or sides be x. Remember, because the remaining angle is equal to the remaining sides. The remaining exterior angles be x. Therefore, we know that the sum of the exterior, because we are given exterior angles, the sum of the exterior angles is always 360 degrees. So we have 30 degrees plus 60 degrees plus, they told us that each of the remaining one, each is 27. So we now have 27 degree times x. Yes, since each is 27, we have x of them. So we multiply by x equal to 360. So let's solve for x. So this 30 plus 60 is 90. So we have 360 minus 90. And 360 minus 90 is 27 degree x. So degree, x is now 270 over 27, which is 10. So the remaining angle or the side is 10. Therefore, the sum of the interior angles is always n minus 2 times 1/8. Since we have the remaining side to be 10 plus the 2 given, so which implies that n here is 10 plus 2. We have 12 sides. So we have 12 minus 2 times 1/8, which is 10 times 1/8. So we have 1,800. So that's the sum of the interior angles. The next one, a regular polygon is a polygon with congruent sides and angle. So a polygon is regular if they have, in geometry, congruent means equal. So in a polygon, if you notice that the sides, so I'm using this as the side, double hashes. So if all the sides are the same, so if here is 2 cm, the other side will be 2 cm. And also the interior angles must be the same. So if here is theta, 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 here is theta. So also if here is beta, here is beta, here is beta, here is beta, and here is beta. So they must have equal angles and sides. And there is one that we need to get formulas here. We need to get each of the interior. Since they are equal, we can note each of them since they are equal. So what are we trying to say? Since the sum, so we're talking about the interior angle. Since the sum of interior angles, we are getting three formulas here. Of a polygon is n minus 2 times 1/8. And since they are equal, to get each of them, I divide by the number of sides. Yes. As example, now if you have 5 oranges and you have 5 people to share, each of them will now get 5/5, which is 1 orange. So each interior angle of a regular polygon, we're talking about a regular polygon, is now the total, which is n minus 2 times 1/8 over n. Yes. And also, since the sum of each of the exterior angles is 360 degrees, each exterior angle is now 360 over n. So that's another formula. So we have how many formulas now? We have 2. This one, but we're going to use, most questions will come this way, and this. And also, finally, we have the exterior angle. Sorry, the central angle is always equal to another thing, that the central angle is always equal to exterior angle. Yes. So for any regular polygon, the central angle, maybe if you have a center, the central angle, that's the angle formed at the center, will be the same as the exterior angle. So that's the three formula. Each of the interior angle is n minus 2 times 180 over n, and each of the exterior is 360 over n. Finally, the central angle equals the exterior angle. So let's look at this question. They said, if 3 regular polygons are arranged as shown, then A is dash. Okay. We have, as you can see, they said 3 regular polygons. So, how many sides? N is 5. 1, 2, 3, 4, 5. So, to calculate, because we are looking for this angle, once we know the remaining, we use angle at a point. Remember, angle at a point is 360. So once we're able to get others, we are done. So how do you get each of these? Let's call it x, or maybe let's call it theta. Let's call it theta. So you see that theta, which is each interior angle of a regular polygon, is now n minus 2. 180 over n. So in this case, we have 5 sides over 5. So we have 3 times 180 over 5. So which is 3 times 5 in 18 is 3. Remaining 30 is 6. So we have 36 degrees. So 36 times that is 108. So each of them is 108. Therefore, if we sum angle at a point, is 360, meaning each of them theta. So we have 108 plus 108 plus 108 plus A is equal to 360. Yes. And 108 plus 108 plus 108 is, that's times 3. 3 times 8, 4. And that's 230. So 324 plus A equal to 360. So we have A is now 360 minus 324. So I have the answer is 36. So that's it. A degree is 36. So A is 36. Our answer is option A. So it's a very technical, question. The next one, they said A, B, C, D, E, F is a regular polygon. We're asked to find angle AGF. So if you are looking for angle, this angle is meant for the middle letter, AGF. So we're looking for the middle angle. So where is A, where is G, where is F? So we're looking for this. So let's call it theta. And how do you solve this? It's simple. We are given that A, B, C, D, E, F is a regular polygon. So all the sides are equal. All the sides are equal. And if we know that all the sides, what's the name of this polygon? This is a six-sided polygon, hexagon. So each interior angle, is 6 minus 2 times 180 over 6, because n here is 6. We have 6 sides. So we have, this is 4 times that. This should be 120 degrees. That's 4, and that's 120. And since this angle, this is 120, this is also 120. This is 120. If you notice, you see that here is A, B, and F. This is 120. And we have these sides equal. So what's the name of this triangle? We have an isosceles triangle. And you know, an isosceles triangle, even if you don't know, an isosceles triangle means two sides are equal or congruent. If you don't call it equal, you call it congruent. So that's it. And since they are congruent, these two angles opposite the sides will also be equal. So since I have 120 here, each of these will be 30. Since the total angle, the sum of angle in a triangle is 180. Since one is 120, the remaining are the same, meaning that each will be 30. So I'm saying that this angle here, this is 30. This is also 30. That same logic here is also 30. Here is also 30. So what do you have to hear? What do you have to say? Look at this triangle. Look at this triangle B. Look at this. Look at triangle A, B, and G here. I've gotten here to be 30. I've gotten here to be 30, yes. Using the same logic. Here is 30, 30. This is 120. The total here is 120. So here is 30. Here should be 30. So this is 90. Why here is 30? Do you understand? I'm saying this interior, each of them is 120. And since I have gotten that these ones are 30, so this is 90. So looking at this, remember we are looking for this angle, theta, which is simple. Theta will be equal to 30 plus 30, which is 60. Yeah, we call it exterior angle theorem. Even if you don't know it, we can still get it from here. Since here is 30, here is 30, here is 120, making here to be 60, angle on a straight line. So if here is 120, here is what? 60. Or you use the exterior angle. If you add it in any triangle, if you add the remote interior angles, So if you had, maybe if here is A, if you add B, you get C. So C is A plus B. Or if you have here E, maybe here is F. If you add B and F, you get E. Or if you have G here, if you add A and F, as this and this, you get it. So this is called exterior angle theorem. So it's very easy to solve. That's our answer. Our answer is option B. So there's what? This is the most technical part. We call it area of a regular polygon. We can only get area of a regular polygon with a formula. Others, you can't get it. You partition it. So, but before then, we need to learn what we call apodem and the radius of a polygon. So let's define that. The apodem of a polygon is the perpendicular distance from the center of the polygon to a side of the polygon. So if you move perpendicular, perpendicular means something that makes angle 90. So this means angle 90, perpendicular. So the perpendicular, not just any other distance, the perpendicular distance from the center. So if you have the center of this polygon, so and you move perpendicular to a side, see the side, forms angle 90. So this is the apodem. So this is the apodem. Let's denote, let the apodem be P. Sorry, be A. Apodem is A. So the distance from this center O to this point is the apodem. So OA is the apodem, A. So that's it. And also we can still define it at the radius of the circle. If I want to inscribe this circle, see the circle in white. The radius is A. So the radius of an inscribed circle is the circle that intersects that touches each of the sides at only one point. So this is the inscribed circle. So if you don't call inscribed circle, the radius of the inscribed circle of a polygon, you call it the apodem. So that's for apodem. We now move to radius of a polygon. The radius of a polygon is the distance from the center to the vertex. So I'm saying that if you see the vertex, so this is the vertex, this is vertex, why this one is side. So look at the difference, the distance from the center to the vertex, this is the radius of the polygon. And why this A is the apodem. So that's the difference between the apodem and the radius of the polygon. We can still define radius of a polygon as the radius of the circumcircle. Yes. Inscribe is inside. Circum is the one that carries. Okay, let me just scale. If you draw a circle, let me use red. Passes through the vertices. So do you see it? This is now the radius of this circumcircle. This one outside is called circumcircle. This one is inscribed circle. Why the one in red is circumcircle. So the radius of the circumcircle is the radius of the polygon, while the radius of the inscribed circle is the apodem. So that's it. And we need to get a formula for the areas. So we need to get a formula. If you notice, if I join, let me get this. Let me get, okay, look at this. You know, this is a regular hexagon. I will use a hexagon to prove that. If I join this, the vertices, you will notice that we will form 6 equilateral triangles. Yes. Let's join. You see. Or maybe let me change this to black. Let's change it to black. Let's change it to black. So let's join. We want to get a formula for that. We're almost done. So what do you notice? We have 6 equilateral triangles. Yes. Because this is a regular equal, so equal sides. This is the radius. Yes. We have 6 equilateral triangles here. So what am I trying to derive? I'm trying to derive that area of this regular polygon is equal to the area, the summation of area, that's the sum. This symbol sigma means sum. Sum of area of the 6 triangles. We'll have 6 equilateral triangles. And we know that area of a triangle is half base times height. So since I have 6 of them, if I know the area of one, I multiply by 6. So I have 6 times area of one of them, like this one. Area of a triangle is half base. The base, okay, let me call the side. The side of this triangle, that's the polygon. Let's call the side. Let's call it x. So this side is x. This side is x. This is also x. So the side of the triangle or the side of the polygon is x. So our area will now be half times the base is x times the height is a. Yes. And you know multiplication is commutative. Yes. I can arrange this as half times 6x times a. And what do you notice? 6x means how many sides are here? 6. So if I sum, means the perimeter. So I can now say that the area of a regular polygon is now equal to half times the perimeter times a, which is the apple. So we've gotten the formula for the area of a polygon, a regular polygon. Half times the perimeter times the apodem. So I used a hexagon so that you can easily visualize that. Even if you use any other polygon, it's still correct. So let's solve this question. So this is the last 2 questions for this tutorial. So they said find the area of a regular pentagon of side 6 and apodem 8 cm. So without wasting time, the area of the regular pentagon is now half times perimeter. What's the side? Pentagon is 5 sides. So I have 5 times 6. As each of the side is 6 cm times the apodem is 8. So our answer is we're almost done with the answer. So I have 5 times 2 in 6 is 3 times 8. So 5 times 8 is 40. 40 times 3 is 120. So 120 cm squared. So that's the area of our regular pentagon. And this, whereas find the area of a regular hexagon if the radius of the polygon is 8 cm. So this is a technical question. Let me copy this. Know if I can copy. Let me use it as the solution. Okay. And let me still copy this so that you see what is happening. Okay. I'll use a side. for this. Remember, the radius of a polygon is the distance from the center to any of the vertices. So I'm using this vertex A. And we know that the apodem is the distance, perpendicular distance, perpendicular, so angle 90. So from here to here is the apodem. So, but they didn't give us the value. But we know that this is 90 degrees. And they said the side. Okay, they said they didn't give us the side. They gave us the radius of the polygon, which is 8. So with that, we can get the remaining. But remember, we need to get the central angle. That's where we come in, the central angle of this polygon. Okay, let me just add. Okay, so I want to get this, each of these, the central angle. Yes, this central angle, we need to, let's get it. So each central angle is always equal to exterior angle. And I told you, for a regular polygon, the exterior angle is 360 degrees over n. So we have 6 sides, so 360 over 6. So each of them is 60. So this central angle is 60. That's, we have 60 degrees. 60 degrees. But remember that, you know, this is an isosceles triangle or an equilateral triangle. The height bisects the sides and the angle. So the height is an angle bisector, meaning it bisects, divides the angle into 2 equal parts. So if here is 60, here is 30, and here is 30. So with that, we can get the remaining side because we are looking for the height. We need the height. That's the apodem. We need the apodem A. So, but before I solve it, there is an elementary theorem that will help us to solve this question. It's called 30, 60, 90 triangle theorem. To help us to get the apodem fast. Like I'm looking at it, the answer is 4 root 3. Yes. You'll be wondering how. How is it 4 times root 3? If you have a triangle that the interior angles are 30, 60, and 90, if the opposite, the side opposite 30 is x, just know that the one opposite 60 degree will be the x, the value here, times root 3. Square root 3. While the one opposite 90 will be 2 times x. So for example, if I have this side to be 30, this angle to be 30 degrees, and I have this side to be 4, without wasting time, the one opposite 60 will be 4 times root 3. And the one opposite 90 will be 4 times 2, which is 8. So that's what we are going to use here. So since the one opposite 90 is 8, the one opposite 30 will be 4, from what I just explained. X to x. Why the one opposite this here will be 60? Since this is a triangle, this is 90, this is 30, so the remaining angle will be 60. Therefore, A will be 4 times root 3. First, therefore, the area we are looking for of the polygon, the regular hexagon, the area is now half times, what's the side? 6 sides times the each of them. Each side, okay, from here you see that here will be 4. Since this is 8, you know they form equilateral triangles. So the side here is 8. So this is also 8. So this is 8 times the apodem. which is A, 4 times root 3. So our answer is now 2 in that is 3. 3 times 8 times 4 times 4 root 3. We have 3 times 4 is 12. 12 times 8 is 96. 96. So that's the final answer, cm squared. So the question is tricky. Thank you.